Hello, I'm Dayan, and you're watching Dayan Explains. You probably clicked on this video because you're wondering what the heck a cat wave is. Well, most people have probably heard that light can be a wave or a particle. However, everything is subject to the rules of quantum mechanics at some level. So cars, cats, and yes, even humans can be a wave too. Let me explain why. First off, if you haven't watched my second video on uncertainty, and also my fifth and sixth videos on Schrodinger's cat, or, in the case of the sixth video, Schrodinger's cats, please go watch them now if you haven't. Links in the description. I really should put these videos in a playlist. Anyway, I think most people have heard the phrase at one time or another that light can be a wave and a particle. You may be wondering how this can apply to cats or what some guy named Schrodinger has to do with it. If you are, you probably didn't go back and watch those videos like I asked. If you recall from those videos, I describe a thought experiment where you quantumly entangle two cats in an extension of the Schrodinger's cat thought experiment. Well, when those two cats are inside their boxes, you can't tell where in the boxes they are or even which box they're in. Furthermore, because they are in one quantum system, again, if you're getting lost, watch the videos. Anyway, because they are one quantum system, the cats are actually in all places in both boxes at the same time. If you open the boxes and observe the cats, they experience what's called a wave function collapse. Notice the use of the word wave here. That's right, the cats were actually a wave and not cats before you opened the boxes. Well, actually they were still cats, they were just cat waves. See what I did there? Light, when it comes from a light source, like a laser, is just like those cats, but much smaller. Basically, they are very unlikely to interact with anything, even in the air. As they get further from the source, their exact locations become less and less known and start to overlap. They become entangled, just like the cats in my sixth video. So considering all this, how do we know the light is actually a wave and not just a column of particles that are in all parts of the beam at the same time? Because of a neat little experiment known as the double slit experiment. This is one of those experiments you can perform at home with a laser pointer and a cereal box. In fact, it's a very popular experiment in high school and college physics classes. This is the setup. You take a laser pointer and aim it through two tiny slits cut into a box, hence the name double slit. You want to cut the top of the box off so you can see the light that gets through the slits, projected on the other side. If you do it right, this is what you should see. This is an interference pattern. It's caused when the waves of the light interact with each other. So, when the light particles finally hit the back of the box, they are more likely to show up places where the waves are high, like this double slit simulation. One of the interesting things about this is that even if you can detect the individual photons hitting the back, you have no way of knowing which slit they came out of. If you try and figure it out by putting a detector in the slits, which is called a which way experiment, the wave function collapses and you get a diffuse pattern. It's like the light is acting as particles now. This makes sense if you think about it in the terms of the entangled cats thought experiment. Putting a detector of some sort in the slit reveals which photon is going through. This is exactly the same thing as opening one of the boxes and finding out if you have the black cat or the white cat. So with this, could you create a cat wave interference pattern? Well, yes and no. At least not one that you could discern. Like I touched on earlier, cats, and actually everything for that matter, has a wavelength like light does. The more energy the object contains, the shorter the wavelength. The smaller the wavelength, the smaller the slits need to be to see the interference pattern. And the larger the object needs to be to contain the energy. Like I mentioned in my 6th video, even if the cat is traveling as a wave, if the hole is too small to fit even one cat, the cat is going to have an issue. So, at a certain point, things get too big and have too much energy to perform the double slit experiment. Surprisingly, even if you shoot the photons out one at a time, they still create an interference pattern. So, one photon is traveling through both slits at the same time and interfering with itself. If you perform this experiment with a cat by putting one in one of the boxes I described in video 5 on a remote trigger, which then opens inside something like a giant vessel with no particles in it, basically an even larger Schrodinger's box. And the cat was wearing some sort of spacesuit that blocked all the thermal emissions, then you could perform the experiment using cats. As long as the slits were big enough anyway, or, you know. However, after the cat hit the detector, you could tell which slit it came through because its wavelength is too small to interfere after it comes through the slit. Unless your experimental setup was light years long anyway. Hopefully it's obvious from my analogy that when you call something a wave, it's not that it's physically a wave. The wave is actually describing where you're most likely going to find an object that isn't interacting with anything else. So, if the wave is a light wave, it appears brighter where the wave is high because you find more photons there on average. Anyway, I think I'll tie it up with that. This video is a stepping stone for more. You can't skip a floor when you're building a house. So, if you like this video, please press the like button, subscribe to my channel, and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people who support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.